Okay, let's start today's class. So, hi, I am Joydas Purako. I am pursuing my PhD from IIT Kanpur, and my research topic is broadly about game theory. And from today onwards, we will learn the basic concept of game theory, or rather, I will say the some equilibrium concept of game theory. Game theory is a very vast topic, so in few lectures we cannot cover whole aspect of the game theory. And basically in a game theory there are there could be separate full semester course should be designed in one topics. So for example, uh, game theory can be divided. So let me start with this game theory. In the game theory, basically two three parts are there in game theory. One is classical game theory. Classical game theory, and it talks about that how rational individuals takes decision under uncertainty or under in strategic situation, take decision in strategic situation. And second is behavioral game theory. So in the first classical game theory, it's only talk about theory. So this part is only about theory and theory mathematics, and it deals the game theory through a axiomatic framework. However, when the psychologist and economist tries to conduct some experiment and try to see whether or not the classical prediction of the game theory matches with actual human beings, and they felt that there are several axioms related to classical game theory is problematic, and due to that some of the prediction actually uh, do not matches with actual human beings. So then it comes that in reality humans are not fully rational. Their rationality is bounded. They do not follow some kind of axiom. Then the behavioral game theory started, and don't worry, I will talk about each concept, that rationality, strategic interaction, and those axioms little bit briefly in this course. So since this is a very introductory course, and I will talk everything about I talk I will touch upon every topic very briefly. And third is completely different. Now this third part of the theory is developed for the purpose to explain, means in natural world we always see it is not only human but also the animals who are non-human animals also, we will always find they are also in a some kind of strategic interactions. Now in they are in some conflict. So if we watch Discovery Channel on National Geography channel, then we will always find that two male lions um, fighting with each other for getting a pride, and also two male deer are fighting with each other, and these fighting and there's two groups are fighting for their territory. So these fightings and the outcomes will depend on the each of one's action. So these kind of situations can be think about in the lens of game theory. So we cannot think that we cannot for sure for sure we cannot say that animals are animals can take decisions rationally as humans do. Rather we can say we can say that uh, they can take decisions, but their decisions can be explained in another way in evolutionary lens. And then this theory come where the strategies are genetically inherited and their strategy does not change in their lifetime. Their strategy is decided from their birth, and it comes from their parents. So this field is called evolutionary game theory. Evolutionary game theory. And here the main question is how some strategies, how some real human. Another question is how some how some strategies how some strategies evolved and others strategy extinct. So these are the basic questions of these three main topic of the game theory. Now why question is why we are interested in game theory. So let us see the question why we are interested in game theory. So if we assume that, or it is not about assumption, there is no doubt that every animal being has its own interest. Now think about a group of animal beings, or animal beings who lives in a group. Then it is very natural that their interests may collide. So first of all, it is no doubt that every animal animal being has some interest. And if there are group living or social living animals, then it is to arise conflict or cooperation among different conspecific. Now if you see, if you in our daily life we encounter, and so you will often find that a large a group of ants subdue and kill some larger prey whose body size is larger than this small tiny ant, but they successfully, with a collaborative teamwork, they successfully kill a larger prey and they take it collaboratively to the nest. So this is an example where the collaboration is happening between the animals, these tiny ants. Now this collaboration is nonetheless in the spirit same as the collaboration what is going on in some collaborative project between some human groups. So you can see the cooperation is inevitable in the natural setting where a group of individuals living, a group of animals living in a social structure. So first of all, so cooperation is inevitable, and also you will find that some two ants are fighting with each other, and in some corner side of road, if you now go to some corner side of road, I will guarantee that you will find some the two ants are you will find, you will probably encounter two ants who are fighting with each other, and they are fighting because maybe they are protecting their territory, or they are demanding the higher amount of, they demanding a larger part of the territory. Now why they are doing so, and if you think that question, you will find that human also do such things often. When uh, two uh, two company fighting for acquiring larger share of the market, they are also fighting in their strategy. So this kind of thing also shows that conflict between two individuals. Now here in the conflict and cooperation, here one interesting thing is, in the conflict and the resolution of the conflict, that is cooperation, in the conflict and cooperation, one thing is very crucial, and one thing is very important, that in both of them the outcomes outcomes do not depend on single individual acts. So suppose that a larger amount of prey is a larger a very large prey is taken by some tiny ants. Now if you think about the situation, if they do not cooperate in pulling and pushing, so suppose here there is nest is there and this is prey. Now if you think about the situation, if every ant pulling this larger prey in random direction, then what will happen, this prey will not reach to the nest, and it will erratically move around the nest, but it will not reach to the nest. So to ensure that the prey will reach to the nest, this ant has to jointly effort, they has to make sure that they are pulling or pushing in the direction of the nest, and by some manner they actually maintain that things, that they all together their total all together they pull or push toward the nest, such that on average the motion of the prey is towards the nest, and that's how by cooperatively their prey moves to the nest. Now suppose that here you can find, you can see that the outcomes is not depend on one individual action, but the action of the other individual. So if everyone cooperate and everyone action is pulling toward the same direction, then only this prey will the prey will reach to their nest, and they will enjoy this, they will enjoy this prey by eating it, or and share this prey with other members. So that's how in a conflict or cooperation, the outcomes of the event depends on what everyone is choosing, not a single individual is choosing. So this is a very important fact, and we find that this conflict and cooperation is universal among every animal beings, and that means human and non-human. In non-human and human, this conflict and cooperation is very common. And another thing we have noticed, that this is a situation where outcomes depend on everyone action everyone's action, and this situation is called the strategic situation, where the outcomes depend on not only one individual actions, but the actions of everyone else, actions of all of the individuals who are there all together. It is called the strategic situation. So naturally we can see that the behavior of the conflict and cooperation in both human and non-human animals can be universally uh, universally uh, can be framed by the strategic interaction. By this strategic situation. So strategic situation, a situation where the outcomes depend on everyone actions. Now, if we, so it is not that recently recently the people has noticed that the strategic interaction is universal, but if we see through the written history of the humans or human literature, through from the ancient time, we will find that humans interest toward the strategic situation is throughout, means you can find the humans in humans all over the human writing from the ancestral time. So if I go back to the time of, means if we go back to the story of Mahabharata, then you will always find that this is the story is nothing but the conflict and cooperation among individuals. So that means, and in other culture also you will find that in the ancient time stories is actually talking about a strategic interaction. And it is very surprising that only you will probably find only the topics that God and love will get the comparable attention to these strategic situations or conflict and cooperation. So that means humans always fascinated about this concept of conflict and cooperation, and this conflict and how they resolve this conflict actually means give rise to some social norms. And not only then humans are interested towards the conflict and cooperation among human society, but some observer marveled also the conflict and cooperation among ants also. So in animal beings also. So there is a African proverb that higher tribe use this proverb of the higher tribe of Tanzania use this proverb, that two ants never fail to, that this is higher, this is higher people of mm, higher people of Tanzania that poor is two ants never fail to pull a grasshopper. So this proverb shows that humans not only not only observe the conflict and cooperation among the human beings, they also observe and the conflict and cooperation of animal beings among animal beings who are living animal beings like ants. So these interests are not mere poetic, that humans are trying to not only limited to the uh, literature. So these interests give birth of such topics: economics, political science. So you will find that in the economics, in the modern era, in the economic and political science, the central question or central theme of these topics are how we can resolve the conflict arises among humans and how the cooperation can be established. So they are mainly focused in these two questions. So that means humans always humans always humans always um, tries to tries to make a universal theory, or takes one's human always tries to understand how this cooperation conflict and cooperation how the conflict arises, and how animals and human beings resolve these conflicts, and resolve this conflict through cooperation and by any other means. Now, to understand this conflict on cooperation and strategic interaction universally, we need a mathematical language. So now we want to say that mathematical we need a mathematical language by which we can easily talk and discuss about the strategic interaction in general. So why we need a mathematical language? So first we see that humans always think things about the conflict and cooperation strategic interaction throughout the human history, and in the modern era, in the you can find that the subject they give rise to a subject that economics and political science and many other social sciences. Now after that, we need a mathematical language to clearly represent the strategic interaction, because the strategic interaction is so universal between humans and animals, and we actually do not say that animals are thinking as humans do, but it is also not doubted that the strategic interaction is inevitably present also in the animal societies. So now we want to represent the strategic interaction through a mathematical language, where we can discuss and exchange ideas of the strategic interaction or conflict and cooperation, how the conflict arises and the cooperation resolve the conflict in. Uh, so we want a language. First, want a language to discuss and generalize process and generalizes the idea of strategic interaction. So why we need a mathematical model, mathematical language? Because it uh, because mathematics, with the help of mathematics we can simply represent the framework, mathematical framework, or the mathematical, by using the theoretical framework we easily enable, means we easily construct the models of strategic interaction in its very very in its essential form. So it will help to construct model of strategic model of strategic strategic interaction, strategic interaction which captures the essence of very essence of the strategic interaction. And third, so it helps us to predict or prescribe the outcomes from very simple rea- simple and realistic assumption. So that's why we need a mathematical theory, because by observing we can form some realistic assumption on some realistic axioms, and from those realistic axioms, through the logical, if I follow the logic I can predict the outcome. So that's why a mathematical language is required to express any concept. So now the the there are many mathematical model which um, we can use, means people use to express strategic interactions. But in this course we are interested specially to a one type of one type of mathematical model of strategic interactions. So one type of model of strategic interaction, that model is game theory. Now the name of the game theory is a little bit, means it is name is a little bit unfortunate, because it seems that it is some kind of it captures some kind essence of some kinds of parlor game. But we will see that game theory not only capture the essence of parlor games, but also some real world situations. Many means every real world game theory can be using game theory one can model real life situations as well. Now let me talk about a little bit history of the game theory. Now modern game theory is modern game theory appears by the seminal work of von Neumann in his papers 1928 and 1937. Although there are papers by Borel in early 20s, in 90s 20s, which is also the foundational work of the Borel, but in the Borel work in the Borel work he conjectured that the minimax theorem is not means minimax theorem is false in general. So minimax theorem is false in general for game. However, he proved that for some of the games, specific classes of the game, he showed that for the specific classes of the game, the minimax theorem, um, that conjecture theorem, that for certain classes game it is true. For certain class of game, he proved that it is true. However, in the von Neumann, it makes more general, and von Neumann proved that it is general and it is true under general condition, and he created the conceptually rich theory of games with more than two players. So Borel only talk about two players game, but in the von Neumann it is talked about more than two player game. Now modern game theory started that when in 1944 the publication of von Neumann and Morgenstern's book. The book name is, and the book is very well written. The introduction of the book is very well written. The book is the theory of games and economic behavior, which appears in 1944. So this book is very preliminary book of the means the first book of the game theory, and these books talked about how we can represent mathematically human interest, and it is like that means as in the book of von Neumann. So first he compared the situation that we sometimes like some things, we prefer something, or we like more than something else, and he compares it with the situation of heat. So there is some feelings of temperature inside us. So when we touch a hot object, we feel that this is hot, and when we touch the cold object, it feels cold. So there is a two feelings associated with the subject, that he can feel which is more hotter, which is more colder than the other. So similarly, in case of preference, there is we prefer some objects. Suppose one individual prefers sweet over sour, and another individual prefer maybe prefer apple over grapes. So there is also his or her preference among the objects. It's all about the feelings. Now the question is, how can we mathematize these feelings, and in physics the feelings of hotness and coldness is well captured by the temperature. and experimentally also it has been verified that we can actually represent the hotness or coldness of a object through or temperature, and it is very successful theory, and theory is thermodynamics. And he likewise he wants to introduce a concept of utility, or if you want to introduce a concept of utility utility associated associated with difference, or we can say that how one individual like something over some outcome A over B, or suppose A outcome is grapes and B is apple. So how we can mathematize the thing, that how we can mathematize the things our individuals prefer apple over grapes. Now von Neumann argue that, so likewise how in thermodynamics, so hotness and coldness in the subject of thermodynamics is captured by temperature. How we can mathematize this concept, that one individual likes apple over grapes, and he introduced a concept of called utility. Now we'll see that what this utility is. And as we means this utility is not a part of game theory, but as you can see that utility is the building pillar of the game theory. So that's why to learn about the utility is very crucial. So let me first, so utility, let me introduce the utility. So utility. So before going to the utility, since we are talking about that one individuals are taking decisions, so here I want to digress and talk about two things. So in the decision making, in the decision making in decision making can be generally categorized into two parts. One is one individual is taking decisions, or second is a group of individual taking decisions. So here the individual is not a social or biological entities individual. So a company can also be an individual taking decisions. So here by individual means uh, means a collection of agents who are whose has a self interest, has only one self interest. So a company has only one self interest, that it wants a bigger market share. So that's why we can treat it as an individual. And group means a collection of a collection of company tries to settle to some agreement about the market, and settles in some agreement to market share. So that is where, when that every individual has some their self interest, and they are coming together, and all together they are agreeing or they are taking some decision. That is called the decision making of the when a group is taking decisions. So a group of individual, and mostly we are talking about the decision making in one individual is decision making, and if time permits us, we will see that in the cooperative game theory how we can model this when a group of individuals are taking decisions. So mostly we are will be in this domain. Our individuals are taking decision in one individual means individual decision making in the individual level. Now in every in these two decision making there are three subgroups are there. One is decision making under certainty under certain condition. Second, so suppose decision making under certain condition, that means the outcomes are certain. So I know that I can means there are several options. So suppose that I have a budget of uh, 20,000 rupees, and I know that what kinds of mobile phones we can buy I can buy with this 20,000 rupees, and I know that. So this is been certain. If I pay the money to the seller, that individual hand over a cell phone to me, and since I know that there are multiple cell phone and I have to choose one among them, so this is a this since I know that if I pay the money I will get the phone certainly. So that is here it is called the decision making under certainty. Now another thing is decision making decision making under under uncertainty. So here the decision making under uncertainty means, suppose I know that two political parties are there who will run. If some political party is win in the vote, then that political party will rule the country for 5 years. Now I know that if I vote for some party, there is a chance that that party will win, and I also don't know that if that party will win, that party will do good for the publics or not. So this is a uncertain situation. So I have to take a decision out of uncertainty whether the party will do good for the public, and second, that whether that party where I am giving the vote will win or not. So this is a situation for the decision making under uncertainty. And there is a third kind of situation is called the this is a I will say this is a subgroup of the decision making of certainty, is called the decision making under risk. So this is again the same situation, but now I know that with what probability suppose with x probability I know that the political party will win, and that party will do good for means I know that party will do good and for sure, and because which is in reality which is which is very uncertain event. But let me give another example. Suppose I am buying a lottery, I am buying a lottery, and in the lottery with probability x I will get 5 rupees, and with 1 minus x I will means I am buying a lottery by paying 5 by paying maybe 6 rupees, and I know that with probability x, and x means there is a chance of 50% chance that I will get 5 rupees, or I can get 50% chance I can get 7 rupees. So this is a lottery where I know that with some probability I get some amount, and with some probability I get some amount. So since the probability of the uncertain events are known, so it is called the decision making under means the decision whether I am going to buy this lottery or I am not going to buy this lottery. So this decision is called the decision making under risk. And why this is called, these two situations are different, by which in the first situation I cannot associate probabilities, but in the second situation I can associate probabilities with the events. So that is the thing. So in this course I will only talk about the first and third. The second is out of our scope, so we only talk about, since we cannot represent with probability, so how we will how we will handle the situation we don't know. So it is out of our scope, so we will only talk about in this course these two, the decision making under certainty and the decision making under uncertainty. Let us then first see what the decision making mathematically, what is decision making under certainty. Decision making under certainty. So decision making under certainty is boiled down to a maximization or minimization problem. So suppose there are n options, suppose a1, a2, small n options are there. Now the decision making problem is I have to choose one option which maximize or minimize some index. So suppose there is a index function which is f of index function is means it gives a number to a1, a2, and now these index functions are real number. So now the question is boiled down to I have to choose one options in which my index function will give me maximum number or minimum number. And the main problem in the decision making under certainty is the more challenging problem or more harder problem is how to find the index function. There is no general rule of finding such index function. So there is no general rule of finding such index function. However, in economics, in economical problem, this index function is really about this profit or loss. So one individual will buy or select one mobile phone which will maximizes his profit or minimizes his loss. So these kind of things. So the profit or the loss can be treated as a index function, and by maximizing or minimizing one can choose one can choose in the example of mobile phone, it is the maximization of profit or minimization of loss. Both can be treated as the index function. And in the later we will see that in the evolutionary case, this is in the economical problem, but for the case of evolutionary purpose, we will see that this index function can be treated as the reproductive repro, reproductive success. So the number of offspring, who are number of offsprings. So this is in the evolutionary problem. And in the evolutionary problem, no one is really taking decisions. However, as in case of economical sense, however, we will see that we can use the same language for the in the evolutionary game theory. We will see that we will use the same language for the evolutionary game theory as well. So that's it. So that's how in these two cases we will we know that what is the index function. But in general, there is no way that if there is some options, suppose if I present in front of an individual an apple and grapes, so I don't know what will be the index function, what index function should one choose to minimize or maximize, such that I can predict that that individual will select apple over grapes or grapes over apple. So that is another thing. So one may say that the taste, but taste is very subjective, so we cannot say for surely what will the one particular individual's taste. So that is a problem. So in the next class we will see that there is one systematic way, or I will say systematic or axiomatic way, to find out such index associated with option. And we will see that these can be in the next class. I will see that how from two basic axioms we can, if some individuals basic some individuals if some individuals preference obeys some two basic axioms, then we can write this index. And this index is sometimes called utility, and this utility is nothing but a number which represent the preference. So that's it for the today's class. So in the next class we will talk about how we in the systematic way we can find out index associated with option, and how we can means in the tautological sense we can predict the decision making under certain, if we present certain options, how we can predict the choice of the subject from two axioms. Okay.